Okay, so this will be recorded uh, on a cloud. Yeah. Okay, so please continue. Yeah.
Okay. Um, I have done a lot of work in a chip design verification
Mhm,
for Dream Big, for Ethernet Mac, around 100G to 100, 800G spec.
mhm,
Also do the work for the PCIe bridges and do some work for PCIe Gen 6 and Gen 5 as well.
mhm,
And previously, I was working with the Rambus for their RAL development for the IP exec means they need some IP exec for their clients in
mhm,
their IP generator tool. I have to develop this thing, and I have done my masters in electrical and embedded system.
mhm,
That is my this introduction.
mhm. Okay. Okay, 1 second.
Nowadays, I'm working on a stuff like one solution for system RDL to complete uh, RTL design, UVM, model generation,
Mhm.
uh, documentation generation, and doing some standalone things. Means
So
verification for general.
so
That's a thing technology like.
so you're working on solution to convert the system ideal into documentation and the register wrapper and the test and so on, right? But is it a proprietary or like open source?
Yeah. That is already open. So I'm also developing few of the stuff. And once it is capable enough, I will open it.
Okay. Because actually there are multiple proprietary compilers, and since like I saw the very first one, I think in 2008, but each many large companies uh, Juniper, AMD, many other, and I think this started from Cisco, use
Yeah.
some sort of system ideal toolchain, and uh, many of such like tool chairs are internal tools. So actually, I'm not aware about open source tools. So is there any open source tool?
Yeah, there is a compiler, system RDL compiler, that is already open. That is compiling our system RDL file to a Python version that can be converted into anywhere, like a um, smaller one from for the RTL generation, for UVM generation, and also for few of the other things, but it is little scattered. And their system RD system Verilog version is very complicated. And I was using some industrial standard to complete to compile the RTL.
Mhm.
That is one of the good thing for the system RDL is it is handling all the type of the registers and their fields, but that is not been possible in IP exec.
Mhm. Mhm. Uh, so wait, like I'm a little bit confused. So like I'm working in like open source like ideal compiler or not?
It is using open source compiler.
It is in open source. Yeah, okay, this is fine. Yeah, this is actually interesting topic because for those who don't know, uh, many projects project in GPU in AMD and Samsung, and especially like networking companies like Cisco, Junipers, they have in their chips like thousands of registers. And basically software, not like register in like RTL sense, so not just simply D flip flops, but memory mapped registers used by software driver. So software driver talks uh, through those registers with the hardware, and also various blocks in the hardware subsystem talk to each other through such such registers, and they pass information about like all the settings, options, and so on. And in addition to it, in both networking and in GPU chips, there are multiple states, different streams of networking packets, or different streams of graphical primitives in GPU, and you need to have a set of register for each of such state. And for this reason, um, we need such language, and we start from a common language which like tell about each memory mapped register information, like size of register, sets of register, how different registers maps into address space, and fields about each register. So you can see in this example that a field in a register can be write only, read only, can be sticky bit, can be to do some action on read or write. So you specify it using special language, which is like different flavors of RDL, and then software can generate from this RTL, or it can generate documentation, or it can generate software driver. Yeah. So maybe we will eventually include RDL in our examples. So I need to really like study this question, how standard RDL is widely used, because many RDL tools in like large companies are proprietary and they have different formats. Yeah, but this like interesting topic for it. Now, like a little bit of what we are doing with this group, and this is both some people here in California, but also like in other countries in like including like Russia, Africa, like even like in like South America. Uh, uh, and so what we are doing is that we are doing a set of examples which in three different GitHub repositories. So, and the goal is to create examples both for introductory seminars and also for more advanced examples for level of interview to large electronic companies. And so like you like as you probably know, uh, many introductory courses in schools, they go into like finite state machines and like various like simple logic primitives, but they don't really teach how to deal with like pipelines and connected with FIFO, with credit counters, and also they don't teach verification, including UVM, but not only UVM, but more like in general self checking test benches. So we have some like opportunity uh, to create such examples as well. So do you, Sultan? So do you work mostly on RTL side, or verification side, or EDA tools?
Mostly I'm working on the verification side.
Verification side. So you are writing a system Verilog test benches, right?
Right.
Yeah. So we have, yeah, we need to. Can you turn it up?
I already turned it down.
But this just creates echo. Oh, can you actually turn off microphone in your place? Okay, okay, good. So yeah, there was some echo. So let me show you some like test benches we did in like as a part of this project, so you will understand. Uh, so we do have like a simple test bench for like every component we work on. For example, let me let me show you uh, system Verilog uh, homework. Uh, so system Verilog homework is a set of examples, and they start from something very primitive, but then they proceed to the like level used on job interviews. Uh, for instance, uh, here is an example of uh, like uh, just a second, let me show you demo in documentation. Yeah, so one interview question is that like suppose you have a pipelined block which computes like square root, and how do you compare formula? And like basically, if you have like if you need to compute a formula square root a plus square root b plus square root c, you can just put three blocks together and add their results, because they just compute such values in a parallel. But if you have formula with dependencies, and uh, for instance, formula square root a plus square root b plus square root c, then you need to like insert either shift register to stage parameters, or to put FIFOs. And there is a person on the call, Kiran, who is working on like documenting such example. But for this example, we do have a self-checking test bench. So let me show you this self-checking test bench. It's not in a UVM. A second, no, it's not here. Register plus. Yeah, here for security formula pipe test benches. Yeah, so we have like a test bench in a system Verilog, which instantiates DUT, which drives clock reset, and which like checks for like a timeout, and then do some direct tests, and like tests back to back, tests with different gaps, and it maintains inside like model of this module. So it maintains log of transactions, and it has inside system Verilog queue, where it stores arguments that come to the front of this block, and then checks against expected results. So we have such like simple test benches, and we have some work in extending those test benches with more microarchitecturally interesting modules. So we also have such example with IXI bus, and we do need somebody to put some of those examples into UVM wrapper, so we can talk a little bit like about this project. I can probably talk with you individually. But in addition to it, uh, we are mostly concerned with examples that can be run on FPGA board or that can be synthesized in ASIC using open lane tools. So, do you uh, uh, do you also work with FPGA boards in addition to ASIC design?
Yeah, yeah, I work on it. There is a one sport for the UVM, which is the accelerated UVM, that is running the actual RTL in our FPGA, and running a simulation in our system, that is taking the transaction from the real RTL and comparing with our system in a
Ah,
UVM.
okay.
That
So
is
you're
available.
putting like prototyping FPGA board, and you put
Yeah,
some like logic and code so that your UVM test bench talks to this FPGA board,
yeah.
right?
There
Yeah.
are a lot of open source tool like Icarius that can run our RTL in parallel of Python UVM. There is a open spec that can be run in a CocoaDB. That is the same
In
type of a
Coco.
UVM, but it have a Python version
Mhm.
that can make the life easier for the open source stuff.
Mhm. Yeah. So I do know that some people, especially people who don't access to system Verilog simulators, they use CocoaDB as a substitute. So we may, it would be nice to create such a combined example. So like you can see that like even without like formula example, we have some examples running on FPGA board, and maybe we can create a demo where you have where you have a part of where you have RTL running on FPGA board, and then it talks uh, with the system Verilog simulator, and we can use either Icarus Verilog and the GPI interface, or we can use CocoaDB. So maybe I will just define this like task for you and see how you can create such a demo, because such demo is very useful, because verification is not properly taught in many schools, and demo when we combine FPGA with a test bench in system Verilog or in the of CocoaDB, it should be good. Yeah. So, but what FPGA do you use?
Yeah, I use FPGAs.
But what kind of FPGA?
Spartan series, few of them, and a few of the Zinc processor, Zinc FPGAs.
Spartan and Zinc. So, like, is it Spartan 7, 6, or 3? So, which one?
6, 7, 6, and Spartan
Okay.
5, not for 7 one.
Okay. Yeah. Yeah. The problem with Spartan 5 and 6 is that their synthesis tool does not support system Verilog, like I see.
Yeah, yeah, yeah.
So, yeah.
But Vivardo is a good enough that can use system Verilog.
Yeah, if Vivado is compatible with Spartan 7, but not
Yeah,
with
yeah,
Spartan 3 and 6. Yeah.
yeah,
Yeah,
yeah.
but if you have like Spartan 7 based board, and maybe I can just send you a link to create example uh, based on one of our RTL examples with RTL running on the board, and uh, system Verilog test bench talking to this board. So do you think this can be interesting for you?
Yeah, yeah, definitely.
Yeah. Okay. So I will send you some more information
Sure,
like
sure.
after the meetup. So now let's talk a little bit about this Gowin board. So first of all, let me let me insert this board and make some demo. Okay. So here, so here is a board. It's called uh, Tank Primer 25K, and this board. So let me share AliExpress. So tank. I need to close this one. Close this one. A second. For some reason, it switched to Spanish. Then primer 25K. Okay, so this board has actually one small module which costs just $26. But in order for us to use it, it's better to use a board called dock. So tank primer 25 dock, and this dock has three P mode connectors and 40 general purpose input output pins, and it also has some P mode peripherals like a 7-segment display and buttons and um, yeah, and it has a DVI and LED, but generally from all those connectors, I plan to use only DVI because for most of our needs, we have a device called TM1638, which is a module which has like a wide 7-segment display and like a bunch of buttons, and this module costs just $2. So we can connect this module using general purpose input output pins, and then we can like we can use this module for like various things. So now yeah, this CP tank primer also has a camera which costs $17, which you can insert, and it has external SDRAM memory, and then it has some things to make it a game machine. And one of markets for such boards is a market for some hobbyists who create like some like old game machines, and I consider this board to be used in like various like seminars which I do like in different countries, because this is sizable and inexpensive. Now you would ask that why do I need a wide 7-segment indicator? And the answer is it's very convenient if you want to demonstrate code, for example, for FIFO. So I have a example. So let's go into examples. Actually, let's start that one. Visual Studio Code. So we have a terminal here. We have a terminal here. So let's get a fresh version of repository. For instance, we have example which demonstrates FIFO. We have example which demonstrates how FIFO works. So let me close this and run that example. Let's run this example in different window. Wait, do you see? Yeah, you can see my window. Oh, for some reason it didn't switch to that window. 1 second. Okay, I will go back to this window. Okay, so we need to close this directory board. So in our repository, if you go to labs and then you go to okay, round robin, Geiger, school disk, yeah, this validate, etc. preview. This has a demo with a debug. Oh, so CD projects. So here you have demo 08. So now, because we just inserted a different Gowin board, we need to run a script called choose another FPGA board. And this script it will ask what board we are running, and we can put here board tank primer 25K doxo, which is board number 51. Answer here, and then we can run a synthesis tool, which is 03 synthesizer for FPGA. And you can see that this synthesis tools works very fast. So this is much faster than like Xilinx Vivado. So it runs in seconds, while for Xilinx this will run for a minute or so. Yeah, so see, it goes already into bitstream.
Yuri, I think you're not sharing the right screen. I'm still just seeing the Visual Studio.
Oh yeah, yes, but in Visual Studio. you should now see different screen. Let me try it again. Yes, screen sharing is paused. Okay, let's do stop share. Okay, let's do start share again. Okay, so can you see it?
Yeah.
Yeah. Okay. Good. So now, oh, on this computer, I actually need to update OpenFPG loader, because OpenFPG loader started to support. Support. Uh, uh, OpenFPG loader started to support this board only very recently. So now we need to go to find OpenFPG loader and maybe build it from source. So let me go back to terminal and let me share. Let me stop sharing this and let me share terminal. So now I will show how to get OpenFPG loader and build it from source. So first of all, I may have OpenFPG loader here already. No, I don't. So let's try to do sudo apt-get install OpenFPG loader. Oh, wait. No, it doesn't have package. Okay, just a second. I will find where I got it. OpenFPG. Okay, so how exactly did they install it here? How did they install OpenFPG loader? So in order to install OpenFPG loader, you can find it in a GitHub. So let me share a different screen. So one problem with a Gowin is that Gowin toolchain works both under Windows and Linux, but unfortunately Gowin EDA tool for Linux does not work properly with FPGA boards, and for this reason, for Linux we decided. So one of participant Alexander Ryabov and Victor Vizovtsev, who was working with him, suggested use OpenFPGA loader. And then I looked to different discussions in internet, and I found that it's easier to just use OpenFPGA loader than to try to fight what a Gowin is what a Gowin is doing. So let me find OpenFPGA loader here. So this is first step to install. Okay, Fedora. Here installing OpenFPGA loader. So we need to install it from source. So in order to install it from source, we need to do git clone of this repository. And now let me share terminal again. Okay. So we need to install. We need to clone repository. Then okay, let's see instruction. Then we need to do cmake dot dot and then cmake build. So we are going back here, and we are so we create build. We create build cd build. Then we do cmake. I don't have cmake. Sudo apt get install cmake. So we also need to install dependencies. So let me install dependencies. Yes, cmake g++. Yes. Yeah, so this support in OpenFPGA loader is relatively recent. So let's wait until it installs. Yes, and while we are waiting, why it takes so long? Yes, finished. Okay, so we can also install dependencies. So we are getting sudo apt install git gzip lib ftdi zlib cmake package config make g++. Yeah, so this is what we have to install before sudo apt get install. Yeah, this version of Linux, which is simply Linux, it requires to use apt-get install, unlike Ubuntu. Which okay, sudo apt-get update. Sudo apt-get update. This uses a distribution called alt Linux. I actually tried this on Ubuntu, but not on alt Linux. If there will be problems with this distribution, I will just use a Windows machine, which uses proprietary Gowin tool. Okay, now let's do it. Let's do it again. Okay, so it doesn't have this. It doesn't have this package. So let's do. Okay, required package was not found. Let's see. Yeah, I will. Okay, so what package should be here? Info module. Yeah, I will resolve it later on. So what I will do now, I will just do it on a Windows machine. So let me switch to a different computer. So I will share screen here. One second. Yeah. So let me share. Stop share here. Okay. Let me share this screen. Okay. Okay, so now like I'm on Windows machine, and here I have this in a project. I set up this 25K board only yesterday, so I need to resolve problems with that distributor. But on Windows it should work. Now git pull. Okay, so now let's go into labs and let's go into valid ready, etc. and FIFO with a better debug. So we are doing this by running script. Choose another FPGA board, and here we put a board 51, which is 51, which is tongue. Yeah, and now we run script which synthesizes for this board. So let's see. You can see the synthesis works very fast here. Yeah, but now we need to connect board to this computer. So, now I need to by the script running FPGA loader. Wait a second. We need to use different script for it. 1 second. What we can do, we can run Gowin GUI. So we can synthesize it here and do program device. Maybe it will work this way. Location is I need to put into settings. Yes, those are various problems which need to be resolved with this new board. So if it doesn't work, I will show with the previous board. So with this board, some pins are dedicated, and when I run script, I just put such setting in the tickle file, but here in a GUI we need to set it explicitly. So project configuration. Okay, let's see. So voltage synthesis general SDC place route. Yes, unused pin. Oh yeah, dual purpose pin. So let's set up everything as a regular IO. So let's put this one and this one as a regular IO. And let's see whether it will synthesize now. Oh, it's synthesized. Great. Okay. So now let's program device. It found device, which is great. So now let's configure it here. Huh. Yeah, we did it. So now you can actually see demo. Wait, which camera is yeah, this camera. So now you can actually see a demo. Where is the camera? Wait. Yeah. I think I need to look here because I have multiple cameras. I have multiple. Yeah, have a multi. So now you can see a demo where we press to like is a push or pop from a FIFO, and this shows how FIFO memory is organized. Let me actually get another demo because this demo is not interesting enough. I mean, I have a little bit better demo for this. 1 second. Because this is FIFO with beta debug 2 and I need FIFO with beta debug 1. So let's synthesize it here. So I need to update open FPGA loader script here, or I can use GUI. So let's first do it using GUI, and then I will modify a script because I added this support only yesterday. Okay, so now same thing. We need to go to project configuration, dual purpose pin, put CPU and I2C as regular IO. And then we are going into process and doing place and route. So you're doing synthesis and place and route. Okay, now we are doing program device. All right. Okay, so you can see. So if you look to the if you look to the camera, we can see FIFO. We can push into this FIFO some new data. You see, and then we can pop from this FIFO. Yeah, so this is demo of FIFO on FPGA boards, and this is general idea why I like to have this wide 7-segment display, that we can do demo even without like uh, uh, putting output to UART or to some graphic display and so on and so on. Yeah, now let me talk a little bit about graphics for this thing. So this board can be connected to a graphical display. Yeah, but actually before connecting this board to a graphical display, let me try to modify script. Oh, why doesn't let me to? It's because I'm doing on different computer. So now, if you close this GUI, we can actually try to modify script so that it will not use open FPGA loader, but instead it will use that one, a proprietary Gowin loader. So there is a script, bash script. So we are using bash scripts for both Linux and Windows. Scripts effectively isolate user from a board because they set up like toolchain and everything based on board name. So now let's go to part of this bash script which configures the board. So we put setup ID and setup FPGA synthesis and configure FPGA board. So we are doing configure Gowin MCs or configure FPGA Gowin O. Okay, and is not installed in the system. Actually, this is a mistake in the script, so we have to modify the script here. Okay. Okay, so this is using MC. So let's modify script and let's see whether it works. So because this is so new, I still I'm still like fixing bugs in this thing. So let's put tank primer 25K, and I think this board is called GW 5A 2024 something, but I'm not sure about the flash method. So let's see what is supposed to be flash method. So first of all, what is the name of this board? So in order to see a name of this board, we are going to get files I got from a GUI. So this is called GW5A LV25. We probably need to get it from a GUI. Let's see whether a GUI generated name of this board for us. I mean, like name of this chip for us. So we are going to validate, etc. Run and see the project created by Gowin. So here is the name of the chip, GW5A25A. Okay. User synthesis PNR bitstream. This is our ethical project, but apparently GUI does not use it. So, okay, this is the actual project. Okay, yeah. So this is a pin name. Okay, disable insert part. Yeah, maybe actually Alexei can suggest something. Alexei, you are here on the call. Oh, yes. Actually, Alexei went away. Let me call him to the call, or maybe later. let's first try to guess without him. This is device CFG. Reconfig IO. So let's just try to guess. If it works, we are fine. If it doesn't work, I will work on this later on. So flash method 36. Okay. Okay, so now let's try to configure this board using a script. Oh, error found. Maybe we should put this flash method as empty R36. Yeah, it didn't configure. Okay, so flash method dash R. So we can try to Google or I will try to figure it out. So now let's try to do some project with a display with a graphics, and I will show you like our graphics option. So first of all, we can use for this board this DVI to HDMI connector. So here is a little screen I have, and this screen has both VGA and the HDMI connections. So what I can do is that I can get HDMI connector, and this board has a P-mode interface, and this connector is supposed to become compatible with this interface. So we can just insert this connector in this interface. Okay. Now the problem is that this is okay. Let me get Alexei, because here I want to show how I connected this using DVI interface. 1 second. Or maybe first I will show how it works with a general VGA connector, and then we will talk about HDMI connector, because with HDMI I really need Alexei, because it requires some additional bridge between VGA signals and HDMI signals. So here is. So here is a VGA connector. Yeah, and if you put this connector into P mode, if you put this connector to P mode, you can actually connect by a regular old VGA connector. And this VGA connector uses interface which is also similar to DVI and LCD interfaces. And DVI interface is can be converted into HDMI, because we have HDMI bridge, and let me show you how this bridge works. Yeah, I will show this later. Let's talk about VGA first. So in the VGA interface, we have essentially signal for red, blue, and green. And we have H sync and V sync. I may go into details, but let me make a demo first, and then we will look to the code. So I need to connect this display. Okay, connect this to power. Okay, so this is just a VGA display, and now let's get a project with the graphics. So one of this board is called simply VGA. One of the slabs with graphics is called simply VGA. And this top module has interface with vsync, hsync, and red, green, and blue. And it instantiates a module called VGA, which generates signals of X and Y, so that a lab user can simply compute red, green, and blue based on X and Y. So like in order to draw a rectangle, you just check that if X is more than 100 and Y is more than 100 and X is less than 150 and Y is less than 400, then you put red, green, and blue in certain values. And if you want to create a picture of ellipse, you're using formula for ellipse and the following formula for parabola. So now let's run this example. So such example is called 06VG, and we run synthesis. Okay, and then we have to run GUI because our configuration from script is not working yet. So now, as we did, okay, so as we did before, we need to go to configuration and put to dual purpose pins and check this as a regular IO, and then we run place and route. Okay, and then we program device. All right, so now you can see that we have the following picture on our graphic screen. Now, if you get a little bit more logic, we can actually create graphical games. Like I have another example with games, but I will not show it right now. I will show later. So now what we need to do is that we need to connect HDMI cable, and we need to try to figure out why this graphics does not work through DVI interface. And for DVI interface, I actually need to get Alexei because I need to explain him my problem with the DVI interface. And this problem is related to a Gowin IP. So Gowin is able to has an option called IP code generator. So it can generate an interface between VGA signals and HDMI signals. So this interface is called DVI-TX. And if you click to DVI-TX, you can see that it like allows different options for this interfaces. And I was trying to create option with using internal clock and put clock frequency on this board, which is 50 megahertz, but it didn't work for me because I need to set some proper settings for LDVS pins. So now let me call Alexei and explain this problem to him. And then probably we'll do some like activity with some local participants. So we will work with the boards here. So you can like hang around online, but I will probably disconnect online part. So let me get Alexei and let's try to solve this problem with the Gowin. So basically in Gowin, we have several files that determines how we map connections uh, between physical pins and pin pin representation in our design, in a Verilog design. Oh, actually, I can show it in here. So if you go to basics, graphics, music, to boards, and if you go to Tank Nano 25K dock, there are several files required by Gowin. So one file is a board specific CST, and this is file physical constraint. So like it says something like a pin K2 corresponds to GPIO 0 in our Verilog. You see, but those pins which work with fast LVDS interfaces, they need to be defined in a special way, and they didn't figure out how they should be defined. So I was guessing this is the right syntax from some examples, but I might be wrong. So we need to specifically put this example, and uh, we have here a clock with a frequency of 50 megahertz, which is defined in board specific SDC file. So for those familiar with Altera and Xilinx, this is very similar to Xilinx XDC file and the Tickle file and the Altera QSF file. And then we have this module which is generated by Gowin IP, and we have board specific system Verilog file, which I started to edit yesterday, but didn't finish. And basically, this module instantiates top module, and the user of a labs usually does not go to this module and usually just look into a top module for the labs. Yeah, but here we instantiate this bridge, so we need to convert uh, vsync, hsync, red, green, and blue signals into this signals uh, p clock n. So this is a high speed interface with a pair of signals, and I need help of Alexei to figure out why this doesn't work. So let me get Alexei here. Okay. Yeah, so now that I will mostly work with the people in the room, so you can hang around, but probably I will not put much online. Hello. Yes, I think Alexei had to go. Okay. 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 Need to get Telegram. Okay. 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 Okay, so I will talk with Alexei about this problem later. So now I will discuss with some participants, especially new, about reporting to other boards, specifically this board. Okay, a second. Stop share. It's here. Okay. 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 Wait a second. Did it turn off video? No, this is a different video. Okay. So, turn on video. Oh, okay. Okay. Okay, so we are going to discuss about support for this board, Tank Nano 1K, Tank Nano 5K, and other boards. So this is just like mostly a lot of hacking of boards, but we are going to interesting problem of supporting camera and high-speed interfaces, something what you cannot do with the microcontrollers. All right. Mm. Okay. So, okay, so what, ну, так что, значит, то есть как вы думаете друг с другом распределить эту вот работу?
Пока никаких контактов.
Я сейчас просто покажу. То есть сейчас нужно отладить всю эту штуку с Говином, потом сделать интерфейс с камерой. Вот. И, так сказать, решать поступающие задачи. Короче, я сейчас просто покажу, как значит, работает. Хорошо. Okay. So, you got this new board?
Yeah, I downloaded it, but I can't find the pinouts for the GPIO.
Wait, this is
This is yours. This is the one that this is the one I just got for $50, right?
Yeah, sure.
And so
Okay.
I downloaded it. It took a while. First time I ran the scripts, the configure scripts was giving me some kind of error, and then I did it again, and it works. So it seems like it's got some kind of dependency on existing environment variables. Right, I can show you how to log it. I was running before it did work, then I ran again and it worked.
Fix all the problems, yeah.
This is probably the one that worked, right? Yeah, this one worked. Right? I was following the same notes as last week. Maybe this is the one that didn't work.
Yes.
Yeah, this is one
Это
thing.
можно такой. Just a second. Let me actually disconnect. Yes, yes, I will probably disconnect. So let's discuss everything individually later on over internet. Okay, let's close this one.
It's much different than software. Software world, everything is nice and neat and tight. Seems like in the hardware world, everything is kind of chaotic. Not so much complicated, it was just messy.